So welcome to the last lecture of Probability and Statistics for Engineer, the episode 21, and I am Mohammad Momenzadeh, the presenter of this lecture. So at this lecture, we will discuss about the normal distribution. We continue our discussion about the normal distribution, and we will talk about the definition and forms and a standard distribution, and we will use a table, and at the end of the day, we will approximate the binomial distribution by using the normal distribution function. So as we promised before, we should talk about the gamma and exponential function, but most of the time we just eliminate this part from the topics of this course, so I will do the same thing in these lectures as well. If you're interested in that type of the topics, you can study by yourself, or you can request it, and I will decide about making the new video for that things as well. But normally the course content will be included this type of the topics that you can see over here. So let us start our discussion by solving some example about the normal distribution. So we start our lecture by solving this example. Given a standard normal distribution, find the value of k such that the following cases holds true. So one of the important things about the normal distribution is finding the points that the probability is given. I mean, the inverse of that things can be considered in the question as well. So for the first part, probability of z less than k is 0.0427. So because this probability is less than half, and as you know, if we consider the normal distribution over here, I have already put the table for the distribution, and as you can see over here, we can put that picture over here to decide about the cases that we have it. As you can see over here, for the standard distribution, half of the distribution belongs to the left and half belongs to the right. And when the distribution probability is equal to 0.0427, means that the point should be lay on the left side of the distribution, means that k should be some point over here. And to calculate the probability and finding the k indeed, you should select the points from the negative table. So let us take a look at the negative table as well. So in this case, as you can see, because the value of the probability is less than half, we should look at the negative table, and we should go through the table, means that over here, and find the value that is given, means that 0.0427. And as much as you just go to the right side, I mean to the 0 points over here, as much as the value gonna be closer to the point 0, the value gonna be bigger. So as you can see, the value at the end of the table is close to the half, and the value at the top is close to the 0, means that minus 3.4 is approximately equal to 0. So because of that, this value lay inside of this table, so we just look on it and we find 0.427 at this point. So you can see that the value is here. So if you just take a look at the numbers that you have it over there, then you can evaluate the value for the k, means that by just finding the cross intersection of that things, you can find the k. For sure, you can say that the probability of a standard deviation, a standard normal distribution z is less than minus 1.7. This is the number that you can find it in a column, the first column, and at the first row you can find the second digit, which is 2. So the z less than minus 1.72 is equal to that given value, which is 0.0427. So you can find that one over there. 427. Right now we found k indeed in this way. So the value for the k at the first part of the question should be equal to that things, means that k is equal to 0.0427. Excuse me, k equal to minus 1.72. So for the second part of the question, we have the probability of z greater than k. So in this case, you should convert that case to the less than k. So let us calculate the value a bit to find that thing. So the 1 minus, let me just start by the terms at the left side, probability of z greater than k. So we know that this value is equal to 1 minus probability of z less than k. So I can convert this value to 1 minus probability of z minus k. So this value z less than k. So this value is equal to 0.2946 based on the information on a question. So to calculate the probability of z less than k, it's only enough to shift that number to the left, and then we can find the probability of z less than k should be equal to 1 minus that term. So we have these things, 1 minus 0.2946, and if you calculate that things by using the calculator or calculate it directly, then you will find this. So we reach to this point that the probability of z less than k should be equal to 0.7054, and this value that we find it over here is greater than half. This value is greater than half, or it should be on the right side of a distribution, so we should look at the positive distribution table. So by that things, we should take a look at the positive table. Here we go, we just put the positive table over here. Let us take a look at the value of 0.7054 inside of the table, and as you can see, we will find it in this location. And by finding the corresponding value at the top and at the left side of that value, you can find the value for the k. Means that over here we realize that based on a information on a table, I can say that the probability of z less than this value, which is 0.5, I find 0.5 at the first column, and in the first row the corresponding second digit is 4, so this value is equal to 0.7054. So in this case we found the value for the k as follows. So the k over here should be equal to 0.54. So for the last question, we have more calculation indeed, and we should write it as a 2 probability. Means that this expression that we have it at the left side can be written or splitted to 2 parts. Means that we can rewrite it as follow. We can rewrite it as a probability of z less than k minus the probability of z less than minus 0.93. However, it's a negative value and you should take a look at the negative part. You can calculate it for the positive part as well. It doesn't matter that it's negative, but you can use the positive table as well. But over here, let us take a look at the negative table. Here I just put the negative table. Let us take a look at the value for the z less than minus 0.93. So the first digit is 0.93 0.9 and the second digit is 3. So I should take a look at the intersection of these two values, and if you just take a look on it, you can find that value. So by just writing and sketching a straight line over there, we will find the value. So we realize that it can be rewritten as probability of z less than k. We don't know what is the value for k, we are looking for that one, and the probability of z less than minus 0.93 is equal to 0.1762. So the given value at the question is calculated, and we have the value of that one. It was equal to that it's equal to 0.7235. Right now we can calculate the probability of z less than k, so we can rewrite it over here that the probability of z less than k is equal the addition of these two probability, means that it's equal to this value, and we should shift the other terms to the right side. So we have plus 1762, so 1762, and the result of this addition can be written over here. So we add them together, the result is 0.8997, and because this value is greater than half, we should take a look at the value inside of the positive table. So if you just take a look on it, you can find it over here. We are looking for that value 8997, and we found it over here. At this point we can find the value 0.8997. so the corresponding values at the top and at the left side of this actually value determine the k. So we realize from the table that the probability of z is less than 1.2. I found this value from the first column, and from the first row the second digit can be found, which is 8. So it's gonna be 0.8997. So we found the value of k in this way by comparing this value and the k, the unknown values over there. We found the value for k. So at the last section of this question, the k can be calculated as a 1.28. Let us take a look at the another question with more complicated cases. So we have another question that has more variable over here, given the normally distributed random variable x with unknown expected value mu and unknown standard deviation sigma. They ask you that to find the numerical value of k such that this probability is equal to 0.54. So right now we just follow the same thing that we should do for this probability, means that let me just put this numerical value at the left and then find the corresponding things that we have it at the right side of this expression. So as you can see, when we have this type of the distribution, the first thing that you should do is making that distribution a standard. And to make that distribution a standard, I should subtract the mu from x, means that I should write it x minus mu, and then I should divide it by sigma to have the standard normal distribution. I should do the same thing for the digit at the right side and left side of this inequality. So if I subtract mu from the first one, this mu will be cancelled, means that mu minus k sigma minus mu, the mu will be cancelled, and by dividing by actually sigma, then the result will be minus k. At the right side, if I do the same thing, if I subtract mu from that one, the mu will be cancelled, and by dividing by sigma, that sigma also will be cancelled. So the result at the right side will be k. So at the end of the day, we have this expression that determine the probability of z is between minus k and k. So this actually value is equal to 0.754. I'm looking for that value of k. But let us take a look at this situation on a shape of a normal distribution. So we have the diagram of the situation over here. The k and minus k are equidistant from 0. They have the same distance from the 0, and this is the standard normal distribution, means that the distance of k and minus k from 0 are as the same. And because of that, the area under the curve between k and minus k is given by 0.754, and we have two tails over here. These are the tails of this diagram. So if you just take a look on it, we have two tails over here, and both of these tails has the same area. If I want to calculate the area of a tail, it can be easily calculated. Means that this tail, the area of this tail is probability of z less than minus k. So this part, this tail that we have, it is a probability of z less than minus k, and at the right side we have the probability of z greater than k. So because the area of these tails are as the same, we can write the total area as 1 minus 2 times of the tails as well. By the other words, from this discussion that we had it at the first line, I can rewrite it as 1 minus 2 times of the tails, 2 tails that we have it over there. Let me just write it by the words first. So 1 minus 2 tails is equal to 0.754. This is the value of the tails. Right now I can evaluate the area of each tail as well. Means that the tail over here, the area of any tail over there, can be calculated as 1 minus 0.754 over 2. So in this way I calculate the area of one tail as well. So if you just calculate that one, you will find the value as 0.123. So by finding the area of a tail, we can rewrite the probability of z less than minus k instead of the tail. We can replace the tail by that one. Means that the probability of z is less than minus k should be equal to 0.123. And because the value of this probability is less than half, then you should look at the negative table to find the corresponding value for k. Let us take a look at the negative table. So I just put the negative table over here. Let us take a look inside of this table, and you can find the corresponding value 0.123. We have 1, 2, 3 at this point, as you can see. If you cannot find the exact value in a table, you should find the closest number over there, but the value is determined at this point. So by just finding the corresponding value at the top and the left side of that one, we realize the value of k or minus k over here is equal to, if you just take a look on it, it will be minus 1.1, and the second digit is 6. So 1.16 is the given value over there. So we found the value of k then. So the k should be equal to 1.16 to have to verify that relation. So we found the value for k in this case, as you can see. this is the answer of this question. So as you can see over here, we have the similar question for the given normal distribution function. In this question, they ask that given the normally distributed random variable x with mean of 100 and a standard deviation of 15, means that x follows the normal distribution with the mean of 100, so I just put 100 instead of mean, and also the standard deviation of 15. So these are the characteristic parts of a normal distribution for a given random variable. They ask you to find k such that the k and k prime are equidistant from mu, and we have this probability over there. So as I said it before, to calculate the probability of x between two values, you should do the same thing to evaluate the random variable as a standard normal distribution. Means that you should subtract mu from that one and divide the values by sigma. So you should do the same thing with the numbers that you have it at the right and left side of this expression. So if I do that one, means that at the right side I have k minus 100 over 15, and at the left side of this inequality we have k prime instead of k, so we have k prime minus 100 over 15. So right now, after that we calculate that expression and transfer it to the normal distribution, then we have the probability of z between these two values, means that k prime minus 100, k prime minus 100 over 15 is a number that you have it at the left, and also instead of x minus mu over sigma, I can rewrite it as a z, or the standard normal distribution. At the right side we have k minus 100 over 15. So again over here we have the similar discussion, means that if we rewrite this expression and sketch the diagram, I can rewrite this value as a 1 minus 2 times of a tails, and tails over here is a probability of z less than smaller value over there, means that less than equal to k prime minus 100, k prime minus 100 over 15. Because these k and k prime are equidistant from the mu, then we can rewrite it as a this expression. Otherwise the tails of that actually probability are not the same, the area of a tails. So when we rewrite it like this, we can find the value of k as well. It's equal to 0.966. right now we can find the probability of one tail, means that the probability of z less than k prime or minus 100, k prime minus 100 over 15. So let me rewrite it over here. 100 over 15 should be equal to 1 minus the given value 1 minus 0.966 over 2, and for sure when you calculate that value it's going to be less than a half, and you should find the value inside of the negative table again. So we found the value as 0.017, and we should take a look inside of the negative table to find the given value. So if you just take a look on it, we have 19 here and 17. At this point is 0017, so we should find 017. So 15 and 17 is here, so don't make the mistake by evaluating as 00. It's 10 over there. So the corresponding value can be found based on these two things. So we find the k prime minus 100, k prime minus 100 over minus 100 over 15 is equal to minus 2.12. So right now you can find the k prime as well. So then k prime will be 100 minus k prime will be 100 minus 2.12 times 15, 2.12 times 15 times 15, and because k is equidistance, k and k prime are equidistant from mu, so k will be 100 plus this value, means that also we can calculate k as 100 plus this value, means that plus 2.12 cross 15, so cross 15. So we found the value of k and k prime by this method over here. So let us solve one practical question about the normal distribution function. Over here, the bottles of waters on the production line are filled according to a normal distribution. If the average volume of water in a bottle is 250 cc and the variance is 100, find the probability that the selected bottle contains more than 200 cc of water. So over here, we realize that if the capacity of the water is determined by the random variable x, then x follows the normal distribution with the average or the mean of 250 cc. So the character of this random normal distribution is 250 for the mu, and the variance is 100. You should care about it. The variance is given, so you should calculate. You should put the standard deviation or roots of 100, which is equal to 10. So this is the character of the x, and at the question they ask you to evaluate the probability of one bottle of water x, the capacity of the water is more than 200 cc, so x should be more than 200 cc. Because this is the continuous random variable, the equality is not change the question, means that this probability and equal as well has the same value. So to evaluate this probability, we should make the variable standard first. So I subtract mu from the x and divide the value by sigma, and do the same thing for the value at the right side of this inequality. So if I do the same thing, means that 200 minus 250 over 10 should be calculated. So 250 over 10 should be calculated, and then this distribution is transferred to the standard form, and then we have the probability of z greater than equal to actually 200 minus 250 is minus 50, and over 10 is minus 5. So this will be calculated as 1 minus probability of z less than equal to actually minus 5. And if you just take a look at the negative distribution, this probability is approximately is equal to 0. So this probability is approximately 0, means that the value of that one is 1. It's a certain probability over there, so means that for sure the bottle contains more than 200 cc water inside of it. So we have one small discussion about the approximation of binomial distribution by using the normal distribution. Over here, if x is a binomial random variable, of course x is discrete, you should care about it, and mu is given by np and sigma square is given by npq. As you know about the mean and variances of the binomial distribution function, then the limiting form of distribution of x with the binomial distribution minus mu of that one over sigma as n tending to infinity is the standard normal distribution. By the in other words, if some condition holds true, that we give that condition in a node, then we can use the normal distribution to approximate the binomial distribution. We use the normal distribution to binomial distribution whenever p is not close to 0. This is one condition, that p is not close to 0 and 1, with the continuity correction of plus and minus 0.5. If both NP and NQ are greater than or equal to 5, the approximation will be good. So we should apply this note in our approximation to estimate the binomial distribution by using the normal distribution. Let us take a look at one example to see that how it's working in one practical example. So we have this type of the approximation over here at the example. You can see the approximation as well, which is given over here, but let us take a look on the example. A coin is tossed 400 times, the n or the number of the tossing is 400 times, and the coin is unbiased. So when it's not given at the question, we assume that the coin is unbiased, is fair, so the probability of tail and head are equal and both of them are half. And as you can see, the p over here is equal to half, which is in the middle of 0 and 1. So of course over here, when we have the probability of success between 0 and 1, means that it's not close to 1 or 0. So the first condition holds true. And let us calculate the NP. The mu, or the expected value over here for this type of the binomial distribution, is given by NP. So n is 400 and the p, or the probability of success, is half. So the result of that one will be 200, and of course 200 is greater than 5. So the approximation is good. Based on the second things that we have it, when NP and NQ, both of them are 200, is greater than or equal to 5, the approximation will be good. So because that value is 200 and also NQ is equal to 200 as well, that approximation is good. Moreover, we can calculate the variance, or sigma square. As you remember that for the binomial distribution, the sigma square, or the variance, is equal to NPQ. So if we multiply 200 by half, the probability of Q, the Q, or the probability of failure, is half. The result will be 100, and again it's a variance, so you should calculate the standard deviation. The standard deviation over here is the roots of variance, roots of sigma square, or roots of 100. So the roots of 100 is equal to 10. So with these two factors, with the mean of 200 and a standard deviation of 10, you should calculate these probabilities and estimate the given values. So over here we can say that the x follow the normal distribution, or approximated by the normal distribution, with the factor of mu as 200 and the factor of the standard deviation as 10. So these are the character of this distribution, and if you calculate that one, you will find the given probability. So we want to obtain the probability between 185 and 210 heads inclusive. So means that we are looking for the probability of x between 185 and also x is between 185 and 210. So because this distribution is discrete, the equality over there is important. You should put the equality. However, in a calculation we neglect that type of the thing. So instead of x, as I said it, we should make it normal, standard. So we subtract mu and divide the terms by sigma. So do the same thing for the expression at this inequality. Then we have the following things, means that 185 as a number that we have it at the left, minus the mu over there, which is 200, and divide this value by 10, and do the same thing for the number that you have it at the right side of this inequality, 210 minus 200 over 10. So this leads us to the standard distribution as follow, means that 185 minus 200 is minus 15 over 10 is minus 1.5. So we should replace it by 1.5 over here. Then we have z as a standard distribution, and at the right side of this inequality we have 1. So because z is between two numbers, we can calculate this probability by evaluating probability of z less than 1, less than equal to 1, minus the probability of z less than equal to minus 1.5. So the first number should be found from the positive table. Let us take a look at the positive table as well. So inside of the table you can find the value. If you just take a look at the table, the value of 1 is here, and also the second digit is 0 as well. So the intersection of these two value give us the 0.8413. So we will write it as 0.8413 as the value for this probability, minus the probability of z less than minus 1.5. So we should take a look at the negative table right now. So this is a negative table. Let us take a look at the given value, minus 1.5. So the minus 1.5 is here, and the second digit is given by 0. So the intersection of these two values given as 0.0.0.068. I hope that I can read it correctly. Okay, so this is the value for the first case. Right now we have the second part of the question as well. In the second part of the question, they ask you to calculate the probability of less than 176 or more than 227 heads. So over here you may calculate the complementary of this probability, or you can solve it directly from the case. So if I want to rewrite that expression, I can rewrite it as follows, means that the probability of number of the heads, which is denoted by x, will be less than 176, when we use or, means that we have the union, and the union changed to the addition because there is no intersection between these cases, or plus probability of x more than actually 227. You can calculate it separately by using this expression, or you can simply write the total, which is 1 minus probability of x between these two values, means that between 176 and also 227. You can calculate one of this expression. The first one is easier because we want to calculate it 2 times over there. So let us calculate it by using the first expression. So over here we should make the random variable standard. To that one we should subtract mu and divide it by sigma. Do the same thing for the second case as well. Second case determined by 176 minus the mean value, which is given as a 200, and divide that value by 10. So we do that one over here, and do the same thing for the second expression, means that plus probability of, again we transfer that random variable to the standard form by subtracting mu and divide the expression by sigma, and do the same thing for the number at the right side, means that again we have 227 minus 200 over 10, and this leads us to the standard normal distribution, and we can rewrite them as follow. We can rewrite it as a probability of z less than equal to that value, so we have minus 24 over 10, which is minus 2.4 for this case, and for the second one we have the probability of z greater than some value, so instead of greater than that value I can write it as 1 minus probability of z less than equal to 2.7. So I just rewrite it in a forms of z less than some value. So the first one should be evaluated from the negative table, and again we should take a look at minus 2.4. so minus 2.4 is located over here. The second digit is 0, so the intersection of these two values should be considered over here. And also we can find the another parts in a positive table. Let us put the values, the corresponding values there. So you can see the value of minus 2.4, and right now we should put the positive table as well to find the value of probability of z less than 2.7 as well. So based on the information that is given in a table, you can find the corresponding value for the probability of z less than 2.7, which is equal to 0.9965, and we evaluate that probability as well. I just finished our lecture in this point, and I hope that you understood the concept of the probability up to this point. I want to emphasize about the remaining topics or the things that you have a question. If you have any question, or if you just find any difficulty in any topics, you can request it at the comments, and I will respond to your actually comments. And if you need more details, or you need more information about any part of this discussion, just let me know about it, and I will put the responding video or responding text about your question. Thank you for attending this series of lectures.